Hi, welcome to Avoiding Memory Leaks. In this section, we are going to discuss what are memory leaks, finding memory leaks easily with Leak Canary, and we'll look at 3 common memory leaks starting with static references, and then we'll move to anonymous inner classes, and finally non-static inner classes. What are memory leaks? In this video, we're going to discuss object references in memory, the garbage collector, and finally how memory leaks get created. Object references in memory. Obviously, when we write our code, everything gets stored in our device's memory. Let's say this grid on the right here is the memory that we have on our device. So we have a 5 by 6 grid here, so let's say we have 30 spaces of memory, or 30 bytes. In our code, let's say we have a list of bitmaps, or a list of images, such as the one we have in our actual application. For this sample, we will assume that our list is very inefficient and it does not recycle the bitmaps correctly once they are no longer on the screen. Now, once an image is no longer on the screen, we don't need it anymore, so we should remove it from memory. And that's actually what happens in the recycler view properly. But for this sample, let's say it doesn't actually do that. Okay, so in our code, we're creating a bitmap and we're storing it in these 4 bytes of memory. After that, we want to load a second bitmap, and that bitmap takes up, and this one takes up 8 bytes of memory. So it takes up 8 memory spaces. After that, for some reason, we have an integer a, and that takes up 1 space. And finally, we have a third bitmap, which takes up 15 spaces. So as you can see, of our 30 spaces, we have 28 used up. If our application is actually using this memory in order to run our application properly, that's fine. But let's say in some code, we don't need a anymore. Let's say the scope was some method, a was a temporary variable, it was an index for example, and we no longer need it. So we can remove it from memory. And as you can see here, the integer is still there, but it's not referenced by anything. And that's where the garbage collector comes in. So what the garbage collector does is it goes through the memory and it checks which objects are connected to something called a GC root or a garbage collector root. We don't need to go into the details of that, but basically the garbage collector checks which objects in your memory are referenced to your code in one way or another. So it goes through and it checks, okay, bitmap is being used, bitmap 2 is being used, and bitmap 3 is being used, which means integer a is not being used and therefore it should be removed. Now let's see how memory leaks get created. Let's say the user scrolls down. And again, keep in mind for this example, we're not using a very efficient list. We're just scrolling down and our bitmaps are no longer being used. So here, the first bitmap that we created, which is called bitmap, is still in memory, but we scrolled up so it's no longer visible to the user, so we don't need it anymore. However, we didn't remove it from our memory, and this is called a memory leak. Basically, it's memory, it's objects that are stored in your memory that are not used and not referenced by your application, and therefore they cannot be removed because of the reference that is there, even though it's not needed. So if you think about it, a memory leak is memory or objects in memory that exist in your memory and are referenced but are not needed. So because of this, we have to be careful how we reference objects in memory so that we can avoid all memory leaks in our applications.